So now I am live. I'm sharing my screen now. So let's go to my PowerPoint. As I said a while ago, then this is all about time rates and it's a ladder problem. Okay, if you say ladder, ladder is a simple machine that will be used to transport. Yeah, as you can see from my illustration here, you can use a ladder to go up and down, a building, or to carry some heavy luggages or baggages. You can go up and down. Okay, this is the man going up the ladder. So ladder problem are actually like a pattern on how to analyze them. So here's the question. A 13-meter ladder is leaning. So 13-meter ladder is leaning against a wall. If you say lean is, if this is the wall, it's leaning like this. So you can see from the illustration, it is leaning against a wall. Okay, and the bottom of the ladder is moving away. All right, from my illustration, it's moving away from the wall at a rate of 2 meters per second. If you say rate is always with a denominator of time. Okay, so it can be a length unit, length over time, so meter per second, kilometers per hour, miles per hour, centimeter per second, and so on. So rate is always a denominator of time. At what rate is the top of the ladder sliding down? So if you put the ladder on this kind of position, then, and if you're going to step on it, then it, like where the man is now, then the bottom of the ladder will go to the left and the top one will go down. As you can see from here, from my illustration, it goes down, wasn't it? So I will make that heavy. It goes down. And this one on at the bottom will go left. So at what rate is the top of the ladder sliding down? So how many meters per second will be the rate of the ladder in going down when the bottom of the ladder is 5 meters from the wall? Now, as you can see, we form a right triangle here, correct? There is right triangle there, and everything will be from this analysis. You have 13 here, you have X here, and you have Y here, and this is your ladder. Okay, so let's go to the analysis. So for the solution, step 1, start with the equation for the ladder. How is it done? So let's get the triangle form. This is the ladder. It is 13 meters hypotenuse. We don't know the Y. We have the X, which is 5 meters. Okay, so first off, don't put the X mean time. That will be substituted later after we had done the derivative. So let me just take the off mean time. Now, we have here a Pythagoras theorem so that we can calculate or we can express X in terms of Y. We said that if this is a C and this is an A and this is our B, Pythagoras theorem says C squared is equal to A squared plus B squared. The sum of the squares of the two sides is equal to the square of the hypotenuse. Our hypotenuse here is 13 squared. Our A is X. Our B is Y. that's why we have this formula. 13 squared is 69, and then x squared plus y squared. You always start with this Pythagoras theorem in ladder problem. So equation 1 is from Pythagoras theorem. After which, you're going to do an implicit differentiation. Okay? Implicit differentiation means I have x squared here plus y squared is equal to 169. Why implicit? Because, why implicit? Let me just cover this one time so I can write in them. Why implicit differentiation? Because we don't have the y is equal to a function of x, like 2x squared plus 3x and so on, so that we can get dy over dx straight away. We don't have that. What we have is a y inside an equation, and it's not expressed as a single y equal to. So what we're gonna do, this is your prelim exam before. What is the implicit differentiation of x squared? It's 2x dx over dx. We are going to differentiate each variable in terms of x plus 2y dy over dx. That's what we need. And the derivative of 169 is 0. Now, dx over dy can simply be canceled out. Okay? So you only have 2x plus 2y dy over dx is equal to 0. Now, we need dy over dx here. Why do we need dy over dx? Because we need to know how fast is the vertical going down. Okay? So this is the ladder, this is the building, this is the ground. We need to know how fast the ladder is going down. So that is your dy over dt actually. Okay? dy over dt. Okay? And here is your x going to the left. All right. Now, that is in terms of x, correct? Now, because we are going to do a dy over dt, then we can change your dy over dx to dy over dt. Okay, so let's go to the next. We can go to the next one. All right, so this is our y, this is our x, this is our ladder. And because we are going to get meter per second as our answer, so we have dx over dt or dy over dt. Okay, the one I had shown you a while ago is doing the derivative in terms of x. Now we have x squared plus y squared is equal to 13 squared, right? So using the time rates differentiation, implicit. So now we do, it's not in terms of x anymore, but in terms of dt. And this is the one that you're going to use to calculate for dy over dt. A while ago, I said dy over dx, but that is not what we need at this point in time because we are in time rates. So you have 2x dx over dt. Did you see that? A while ago, if you're going to differentiate it in terms of x, that is 2x dx over dx. This is what we are always doing. That's why I did that first before we change it to dy over dt. Plus 2y dy over dx. That is in terms of x. But now we're going to change that to dx over dt. Dx over dx here will be 1. But this time, because it's about time rates, it will be dx over dt in terms of time. So now dx will have a derivative plus you have 2y dy over dt is equal to 0. Okay, now what we are interested in is the dy over dt. What we will do is we can make this one smaller. Hang on. Here. So that we will have more space. Okay, we can now remove this one because this is just a comparison. Now, what we want is dy over dt. So we can move our x to the other side. We'll have 2y dy over dt is equal to minus 2x dx over dt. Now, because there are only two quantities here. Yeah, the 2y dy over dt will be at the left side. The other one, the whole quantity, will be on the other side. Right. If you will ask me, why is it that the dx over dt doesn't get a negative? It is going to get a negative because when I transferred 2x, it became negative, and this will be multiplied to dx over dt. Hence, the product will be negative if dx over dt is positive. Okay, so let's continue. Now we can calculate dy over dt, that is how fast the ladder is moving down the vertical, is equal to, what will I do? I divide everything by 2y. Okay, so we have the 2 and the 2 cancels out, so this cancels, and the 2 and 2 cancels out, so we have negative x over y times dx over dt. You can also do it like this because you always have a question in this. This can also be rewritten as negative x times dx over dt. This is only one quantity over y. What is our x again? Our x is 5 meters. What is our y? Our y is, do we know y already? Oh, not yet. Okay, so we have to find for y when x is 5. So that is what we're going to calculate. And then dx over dt, do we know that? Yes, we know that. That is in the problem 2 meters. 2 meters per second. Let me just see that. It's 2 meters per second. It's here. Here. Okay. So let's go back there, 2 meters per second. How about y? How are we going to calculate that? So we have the right angle triangle. We have 13 here. We have 5 here. This is the one that I was telling a while ago. X and y is that we do not know. But we know that 13 square is equal to 5 square plus y square. So transpose, I'll make this one a bit smaller. Again, shall we do it again, please? I use a thinner pen. So this will be 13 square is equal to 5 square plus y square. We move 5 square to the other side, 169. 169 is 13 square. No, I will not do that yet. Okay. So that is 13 square minus 5 square is equal to y square. Or y will be the square root of 13 square is 169 minus 25, 5 square. So y will be equal to 169 minus 25. 9 minus 5 is 4. 6 minus 2 is 4. 1 minus nothing is 1. Okay, it's 144. And the square root of 144 is 12. Makakagatin niya ako. That is, no, i-open mo yung ano. I-open, no, Han, i-open mo ito and then lalabas siya. Mahirap yan. Baka mas makagat ka. Bakit kasi? No. I-open mo muna yung ano, door. Sorry. The mouse got in. I was bitten by the ano kasi. I was bitten by the thingy, by the cat. Anyway, we are there. Morning is here. Look. There. You know this cat? This cat is blind. Yeah. We call her Ulag. Okay. So anyway, let's calculate. Sorry for that. Okay, so we have square root. That's funny, isn't it? Square root of 13 square minus 5 square. Careful ka, baka maano ka. That is 12. Undisturbed. Okay, so that's it. Y is 12. Okay. Sorry for that, okay? You can skip that part, please. Right, so y is 12. Now, let's solve for dy over dt. I'm going live eh. Paano nakapasok yun? Paano nakapasok yun? Huh? Thank you. Because you do not know how to use the slippers. Gagamit sila ng slippers, ilalagay doon right after the door. Kaya pupunta ang ano. I don't know. You're always like that. You're leaving your slippers. Ganun lang. You cannot think na you have to leave it away from the door. Dapat sa side ng door, you leave ang slippers and then you get in. Anyway, patalastas po. So, and that is done many times, but still no improvement. All right, so dy over dt will be equal to negative 5 over y, which is 12. Dx over dt will be 2. So dy over dt is equal to 10 divided by 12. So 10 divided by 12 is actually, hang on, let's do it, negative 10 over 12 by 2, so that it will be 5 over 6, negative. Let's do it here with a calculator. All right, so you have fraction, and then negative 5, down, 12, and then times to the right, times, or you don't need to do that, you can just do a bracket times 2. That is negative 5 over 6, which I have here, and do SD. So it's negative 0.833. So dy over dt is equal to, let's just put it somewhere that is more spacious. Dy over dt is equal to negative 0.833 meter per second. What does it mean? What is the negative wants to tell us? The negative means it's going down because our positive is going up. Our positive is going up, okay? Going up is positive, going to the right is positive. Any direction that is against our assumptions here, down will be negative, right? Down will be negative, and to the left will be negative. So dy over dt, because this is along the y, it means the direction will be going down 0.833 meters per second. That is what it means by the negative, is a direction. Okay, let me just check if I write it correctly. All right, so that's how it is. Let's go into wrap it. So number one, you have to set your Pythagoras theorem. Okay, x squared plus y squared is equal to whatever is the length of the ladder. And what's next is you're going to implicit. That's number two. You have to do an implicit differentiation of x in terms of time, not in terms of x anymore. This was just an illustration just for you to recall implicit differentiation. And after that, after the implicit differentiation, okay, you're going to whatever be the variable you're going to look for. Look, for the implicit differentiation, you have cases where, look, x could be unknown, right? Or dx over dt can be unknown, y can be unknown, or dy over dt can be unknown. So there are four possible unknowns a ladder problem in time rates can face you, right? There could be four problems that can face you. So this one, dy over dt, is the one unknown. So if that's the one unknown, you have to simplify your equation, your implicit differentiation into dy over dt is equal to the other three variables, x, y, and the derivative dx over dt, and substitute. Now, in the substitution, either x or y will be given. If x is given, then find for y. If y is given, then find for x. If dx over dt is given and there's no y, then you have to find y, like what I did here. How do you find for y? You have to go back to Pythagoras theorem, and you have to apply Pythagorean theorem from there. Okay, and you will have when everything is known, x is known, y is known, dy over dt is known, then you can find whatever dx over dt is known, then you can find for the unknown dy over dt. So what is the answer? The answer would be 0.833 meter per second, and it's going down. Right. For your work, this is another homework you're going to do to be marked the first day of the final term. So this time is a 15-meter ladder leaning against a wall. You have to must illustrate and follow the example. Okay, thank you. And Mom Debbie is saying thank you to you. 15 meters ladder leaning on a wall. The bottom ladder is moving away from the wall at the rate of 3 meters per second. At what rate is the top of the ladder sliding down? So it is very much similar with what I did. So this is the question. Rate. So let's shade that with a different one so that it will be different from the rest. Rate. What is the rate of the top of the ladder sliding down? What is the rate of the top of the ladder sliding down the wall when the bottom of the ladder is 9 meters from the wall? So it's the same scenario. Okay, you have to illustrate, follow the example I had in my explanation, and put this in your notebook. It will be marked the first day of the final term when I will be giving your midterm exam score, inshallah, and your grade. So this is what we're going to do during the first day of our finals. I will give you your paper, inshallah, of the midterm exam, the result. I will give your grade for the midterms, which is 2/3 of the of midterm plus one third of the grade you had in your prelims. That will be the final um, midterm grade. That will be done on the first day. Anyway, we have 1 hour 30 minutes, correct? Sorry, 2 hours. I should say 2 hours, so we can do all of this in one go. And then we will be doing sit works and maybe another example for inflection points and critical points, and then ladder. Okay. To be honest with you, with all these activities that we're doing, you will be off to go for the finals. There will be rigid differentiation in the final term. This will be a review and a review and a review of all the things that we've done, and then let's see what will still be the missing bits. There are still things that I want to share with you for the finals, but maybe this will just be getting some scores from you. But as to the scope of the final exam, I'm already finished with the final exam questions. Just to be honest with you, my dears. Okay, so some will be. I will just tell you when that time comes. Okay, inshallah, everything will be okay tomorrow and the rest of the day, so we can finish our midterm. Okay, so I'll end from here. Tell the others to watch this video because you have homework here in the ladder problem. Okay, so bye for now. I'm going to end from here as well, my StreamYard, and I'll see you during the exam. Bye bye.